half-angle identities. So half-angle identities allow us to find exact values of trig functions of angles like in example 1, right? We have tangent of 3 pi over 8. So 3 pi over 8 isn't one of those angles for which we can find an exact value. So the directions will say something like use a half angle formula to find the exact value of a trig function of a certain angle. So what that implies is that 3 pi over 8 is equal to 1/2 of one of those special angles for which we can find an exact value. So let's solve for x to see what that angle is. So if I'm going to get x by itself, I'm going to multiply both sides by 2. Or you could think of that as 2 over 1. So this would be 6 pi over 8. And we can reduce by 2, right, which would make that 3 pi over 4. So I can find any of the trig functions of 3 pi over 4, right? So 3 pi over 4, if I think of this as 4 pi over 4, 3 pi over 4 would be pi over 4 this way, right? So that enables me to draw my right triangle in quadrant 2 with a reference angle of pi over 4. So I know that triangle is 1, 1, square root 2. And then I also want to think about what's positive where, right? So that's when we think about this CAST. So sine and its reciprocal are positive. In the second quadrant, everything else is negative. So what I can do now to find this exact value of tangent of 3 pi over 8 is I can use the half angle formula. Now tangent has 3 different variations of it. And you can, all 3 of them will take you to the same place. It kind of just depends on what's given. I can find sine, cosine of our specific angle here, so I can use any of these formulas. So I'm just going to make it easy on myself. I'm going to go ahead and let's use this last one. So if to find tangent of 3 pi over 8, again, I'm using the formula tangent, the book uses u over 2. And we're going to say, okay, that's equal to 1 minus cosine u over sine u. And so basically what we've done over here is we've made a triangle for angle u. So this means that cosine of u is equal to, that would be negative adjacent over hypotenuse, so negative 1 over the square root of 2, or negative square root of 2 over 2. And then I'll also need sine u, and sine u is same thing, right, except it's positive in the second quadrant. So square root of 2 over 2. So again, I'm just going to plug in those values. So this is 1 minus cosine u is negative square root of 2 over 2. And then that gets divided by, go ahead and put that in parentheses. That gets divided by sine u, which is also square root of 2 over 2. So now I just need to clean this up a little bit. So this is 1 plus the square root of 2 over 2, all divided by the square root of 2 over 2. So common denominator in the numerator, I can think of 1 as being 2 over 2. So that would be 2 plus root 2 divided by 2, all divided by the square root of 2 over 2. So we'll take the top and multiply by the reciprocal of the denominator. So those 2's will cancel, and I'll end up with 2 plus root 2 over the square root of 2. So that is our exact value using a half angle formula. All right, let's try another example. So another variation of examples that you'll see within this unit is something like this. Okay, so we're told that secant of some theta is equal to negative 17 over 8. And we're told that theta is in between pi over 2 and pi. Okay, so that tells us that if we're going to draw this, right, here's pi over 2, here's pi. So that means that our triangle should be drawn in quadrant 2. And remember, this is for angle theta. All right, so secant, right, would be hypotenuse over adjacent. And notice that it's negative, which is consistent with what we know about quadrant 2, right? This is CAST. So only sine and cosecant would have positive values. So the hypotenuse is 17, and this would mean the adjacent side is 8. So that would be this. And then we can use the Pythagorean theorem to find the other side. So let's see, we can call the other side anything we want. So that would be a squared plus 8 squared equals 17 squared. So this would be a squared plus 64 is equal to 289. Subtract 64 and a squared is equal to 225. Square root that, so a is equal to 15. Okay, so we know that this side is 15. Okay, so now I can find any trig function of theta. And so notice what we're looking for exact values of is cosine of theta over 2. And then we can also take a look at tangent of theta over 2. So let's jot down the formula for cosine. Okay, so notice it's plus or minus. It doesn't mean we get two values. It means we have to decide which to choose, the positive or the negative, based on what quadrant u over 2 or theta over 2 lies in. All right, so let's jot this down. I'm just going to write the formula down here so it's in front of us, and then we'll talk about which sign to pick. So this is 1 plus cosine theta over 2. Okay, so we know what quadrant theta is in, right? We're told right here that theta is in quadrant 2. But in order to determine whether the sign of cosine of theta over 2 is positive or negative, I need to know what quadrant theta over 2 is in. So if theta over 2, really we need to divide all of these by 2. We need to manipulate that inequality. So theta over 2 would be in between pi over 2 and pi over 2 is pi over 4. So think about it. What does that mean? So pi over 2 is right here. So pi over 4 would be here in quadrant 1. Oops, I wrote it 2. So theta over 2 would be somewhere here, which is in quadrant 1. All functions are positive in quadrant 1, so that means cosine of theta over 2 will be positive. So I choose the positive there. So let's see, what else do we need? So we know that this is going to be positive 1 plus, so what is cosine of theta? So that's when I go back to this, because remember this is for angle theta. So cosine theta is negative in quadrant 2. And it would be adjacent over hypotenuse. So that's 8 over 17. And then that's all over 2. So that's the value. Now we just need to clean it up a little bit. Okay, so in the numerator, right, I can think of 1 is 17 over 17 plus 8 over 17, and then this is all over 2. So 17 and 8 is what? 25 over 17, and then that's all over 2. So really that is 2 over 1. So when you multiply, just kind of shortcut, when you multiply 25 over 17 by the denominator, you know what, I made a sign error here. I was thinking, I think we're supposed to subtract, and why aren't we? Let me fix that. That should be, right, that's negative. So let's just go back. Let's backtrack a second. So cosine, like I said, is negative 8 over 17. So this should be minus 8 over 17. Sorry about that. So this should be 9 over 17. And then what I was starting to say is this just kind of a shortcut that I think is good for you to start to think about. Technically, we would take 9 over 17 and multiply by the reciprocal of 2 over 1. So really what happens is you just end up multiplying these two numbers together. So this becomes the square root of 9 over 17 times 2, which is 34. And then we would take the square root of each, the top and the bottom. The square root of 9 is 3, and then we can't evenly take the square root of 34, so we can leave it like that. So our final answer, the exact value of cosine of theta over 2, is 3 over the square root of 34. So now let's do the same thing for tan of theta over 2. So again, we still know that this is our triangle for angle theta. We still know that everything for theta over 2 is positive. So we just need to pick one of the 3 formulas that's listed for tangent. Again, they'll all take us to the same place. So this time let's use sine of theta over 1 plus cosine theta. So what's nice about having these other 2 for tangent is we don't actually have to think about the plus or minus. You would only have to think about it if you were going to use that one. Okay, so I need to know sine. So sine of theta, so sine's positive in quadrant 2, so sine would be 15 over 17. And then that's all over 1 plus, again, we know cosine of theta is negative 8 over 17. We won't make that sign error this time. So this is 15 over 17, and that's divided by, so similarly, we would think of 1 is 17 over 17. So 17 minus 8 is 9 over 17. And so when we multiply by the reciprocal, actually the 17s will cancel, and we're left with 15 over 9, which reduces to 5 over 3. So the exact value for tangent theta over 2 is 5 over 3.